In this video, I'm going to show you how to use JuiceFS in AWS EMR. Now we're talking EMR because it really is the most simple way to use HDFS in the cloud. But rest assured that JuiceFS is actually designed to work with any kind of Hadoop systems, different distributions or installations. To get things going, we're going to first create a JuiceFS volume in our web console. But before that, I'm going to talk a little bit about why we should adopt JuiceFS in a Hadoop system on the cloud. Now, for those of you who are not so familiar with our product, JuiceFS is a distributed file system designed for the cloud. It uses an object storage of your choice to store the actual file data, while the metadata is stored in a separate high-performance metadata engine. This architecture brings a decoupled solution to the big data realm, which in our experience usually reduces the costs by 60 to 70% compared to traditional full-scale Hadoop cluster. Also, JuiceFS client runs on multiple platforms and offers a variety of different APIs, including the Hadoop SDK, which we're going to demonstrate today. Now, that's all we're gonna introduce for now. The rest you can check for yourself in our documentation site. The website is juicefs.com/docs/cloud for cloud service. That's what we're gonna demo today. Now, let's head to the JuiceFS console and create a brand new file system called AWS-POC. We're going to use the Hong Kong region for our object storage in S3. Now, the trash expiration time, let's set it to 7 for data security. And the bucket name is fine. Note that we're going to use the default 4 MB size and uncompressed for maximum performance. Now we're not gonna actually create it because we have prepared that in advance. My colleague Tommy here has already set up everything for me. After that, we're going to create a S3 bucket in the AWS console. This is pretty trivial, so I'm just gonna use one that I have already created. Now this bucket, we're going to use it as JuiceFS file system storage, which means files are going to be split and uploaded to this bucket. And also, we're going to use it as a temporary storage to put our installation files. The installation files contain a Hadoop SDK jar file, as well as a shell script called EMR-boot.shell. Now these two are all the resources that we need to install JuiceFS into the Hadoop cluster. The download links is also mentioned in our Hadoop documentation, which is right here in our documentation site. Click Hadoop under the installation chapter. The Hadoop jar file is right here. And for the EMR boot script, you can simply search and find its download links. After you have successfully downloaded these files, you're going to upload them to S3 to form a URI like this. Now this address is downloadable and we're going to provide it to the bootstrapping process. So now we're ready to create the actual EMR cluster. Let's head to the EMR console. Now for the most part, we're just going to use the default configuration provided by the console. Let's just change the name here. And you might want to click Custom in the application bundle. We're going to select Zeppelin because it's great for demonstration. Now for the rest, we're going to keep the defaults until we find bootstrap actions. We're going to add a bootstrap action. Name it install JuiceFS. You should know that the bootstrap action is going to run on every EMR node, which is exactly what we need to make JuiceFS available to the whole Hadoop cluster. Now for the script location, we're going to use the one that we have already uploaded to S3 earlier. I'm going to paste this into this field, and remember to add the argument as --jar plus the Hadoop SDK jar file. And now we're going to add some software settings, which is shown right here. Paste this into this JSON field. You should also know that this little piece of configuration here has been greatly reduced and simplified for demo's sake. And you can find all configurable items in our configuration section in the docs. Because normally when you run JuiceFS client, you have to provide the object storage access key and secret key so that the client knows how to talk to the object storage. But here we have already created some IAM roles for our EC2 VMs so that the machines can talk to object storage without these credentials. This avoids leaking any more company credentials than we have to, which is very professional for a demo. And finally, let's select the right key pair so that we can access later. I'm going to use Tommy's key, and for the IAM role section, let's use the default role for the EMR service. But for the EC2 instance profile, please add the object storage access capabilities to the IAM role so that you can omit object storage credentials when you're writing the software settings, just like I did. Yeah, we're pretty much good to go. I'm not gonna hit the create cluster button because I have also created that in advance. So now let's pretend that we have already created the cluster, and I can log into the primary node using SSH. I'm gonna switch to the root user, and also keep in mind I'm going to operate under the user called HDFS. Now HDFS is sort of a privileged user under the Hadoop system, so we don't run into any permission issues later on. And also I've prepared some sample data to try out in the HDFS. This is called store sales, and we can take a peek. As you can see, it's just a sort of a CSV file, but the delimiter is a vertical slash. This is not a problem for us. So we're now going to import this 3.8 gig files into HDFS. I'm not a great typer, so I'm just gonna copy the command. Oh, so the data have been imported into HDFS. And now we're going deeper into the Hadoop world. I'm gonna set up a port forward so I can access the Zeppelin notebook directly from my browser. Let's put it here. And then in my browser, type and now it's opened. So let's first navigate to the first code block. This is just a command to verify that the data has been successfully copied to the destination directory. We're gonna run it and to see that everything is working as expected. Next, we're going to drop the table if it exists and create this table again using this SQL. It's gonna finish very rapidly. So now we can describe the table and select a few rows from it. But so far, we're only playing with HDFS here and not actually using JuiceFS in our Hadoop system. So now we're going to interact a bit with JuiceFS just to see that the SDK installation is working correctly. We can use the HDFS CRI to access JuiceFS directly to see that it is completely empty, as is also shown in our web console. We're going to create a test file for better observation. As you can see here, I have mounted JuiceFS as a fuse mount point, and I'm going to create a test file. And after that, I can see this file from JuiceFS. I'm going to run some Scala code just to produce the same result so that we know JuiceFS is working with Hadoop now. We can also use Scala SQL to create a table and insert some data to verify that everything is working correctly. We're going to wait a second and observe the results in the JuiceFS console. So you can see that the person table has been created and a single row has been inserted into the table. And this file is the corresponding result inside the JuiceFS volume. Great. And now we can do a simple data migration from HDFS to JuiceFS. We're going to copy our store sales table using distributed copy from HDFS to JuiceFS. We're going to run this command, and as you can see, it transferred the store sales data to JuiceFS. Now, this is a simple data migration which assumes the source table is static. Now, we also have a seamless migration process that I can introduce later in the next step. Upon completion, we're going to again describe this table and pay attention to the location field to verify that it is actually referencing the data that resides on JuiceFS. So now we can use this table by running a sample SQL, and the SQL returns successfully. That's how you know we have completed the data transfer into JuiceFS. You should keep in mind that this procedure is the most simple way that you can migrate to JuiceFS, which really requires the data to be static, which means applications will have to suspend their rights to HDFS before the data copy begins. Now, if you're not happy with this, you can always choose to perform a seamless migration, which is a little trickier than what we just did. This seamless process will utilize the symbolic link feature provided by JuiceFS. Now, we all know that a symbolic link is just a string in the file system that resolves to an actual file. But in JuiceFS, specifically with the JuiceFS Hadoop SDK, it can actually resolve to HDFS locations. Now, before anything, I'm going to wipe JuiceFS clean to show you what it really means. Everything is gone in the volume, as is shown in the web console here. Now, if we run this SQL again, we're going to run into errors stating that the files are already gone. So now we're going to copy some commands that I have prepared to create a symbolic link that points to HDFS. And you're going to notice that the store sales symlink is actually blinking in red, indicating that it is a invalid file for Fuse, as well as the overall Linux file system, which is true because it is only resolvable by the Hadoop Java SDK. So we're gonna head back to Zipline and run this SQL again. And this previously failing SQL will magically returns the correct results because the files are already pointing back to HDFS. Now you can use this feature to create a seamless migration process, which we have covered in detail in the data migration chapter. That's pretty much all for today. If you have any questions, you can head to the community by clicking the community button in our official site. We have GitHub and Slack. You're encouraged to establish communications with our users as well as the Juice Data team. And that's all for today. Goodbye.